In today's flipped classroom lesson, we're going to learn about the periodic table. By the end of the lesson, you should be able to identify scientists and how they have contributed to the arrangement of the periodic table, explain how rows on the periodic table are similar, explain how groups on the periodic table are similar, and describe physical properties of the four main categories on the periodic table. Dmitri Mendeleev published the first version of the periodic table in 1869. He arranged elements in order of increasing atomic mass. Henry Moseley improved upon that periodic table by arranging the elements in order of an increasing atomic number. The modern periodic table that we use today is still organized by increasing atomic number. It goes from left to right and top to bottom, as you can see below. Each element is represented by a box called the element key. The element key is where we get information about that element so we can draw our Bohr models. Here's an example of an element key using oxygen. The top number, 8, is our atomic number. Right below that we have the O, which is our chemical symbol. 15.999 is our atomic mass. And at the very bottom we have the element name. These element keys are organized into horizontal rows called periods. The periods contain elements whose properties change gradually and predictably. And they are labeled 1 through 7, as you can see below. So why do you think hydrogen and helium are in the same row? Let's see if we can find out. We're going to create a Bohr model of each, see what they have in common, and then test our hypothesis. Here are the element keys for hydrogen and helium. We have an atomic number of 1 for hydrogen and an atomic mass of 1.008. Helium has an atomic number of 2 and an atomic mass of 4.003. Here are the Bohr models indicating that information. Do you notice anything that they have in common? So if you didn't see a pattern quite yet, that's okay. Let's do 3 more examples and see if we can figure out what they have in common. Here are element keys for lithium, beryllium, and boron. And here are the Bohr models for each. Let's look at what we might find in common with these 3. Do you notice how many electron shells that they have? Let's go back to our previous example. How many electron shells are there? Hydrogen and helium both have 1 electron shell. Lithium, beryllium, and boron each have 2 electron shells. So, the number of periods identifies the number of electron shells or energy levels an atom of an element has. Elements also seem to change predictably as you look across a period. For example, it goes from metal to metalloid to nonmetal to noble gas. A physical property is something that can be observed using the senses. That's going to be touch, sight, and smell. We can see this without destroying the object. Examples of physical properties would be number of shells, number of valence electrons, luster, conductivity, and malleability. A chemical property indicates how a substance reacts. Chemical properties can only be observed during chemical reactions. Substances are changed during chemical reactions. Elements react with other elements to form compounds. Our valence electrons determine how the element will react with one another. Our vertical columns, called groups or families, contain elements with similar physical and chemical properties. They are labeled 1 through 18 with an inset of 1A through 8A and 1B through 8B. So here are 3 examples with element keys, 3 Bohr models. Do you notice a trend from these elements located in group 1? Let's look at their valence shell, the very last shell. How many valence electrons are located in that shell? Hydrogen has 1, lithium has 1, and sodium has 1. So our groups and family number identifies the number of valence electrons that an atom of an element has. Groups increase in atomic number as you go down a group, as well as in atomic mass. Elements in the same group tend to react with other elements in a similar pattern. Group 1 elements have 1 valence electron. Group 17 elements have 7 valence electrons. These groups easily bond to form stable compounds. 7 plus 1 equals 8, giving us a full outer shell. The periodic table is also separated into categories based on similar properties. We have metals, nonmetals, metalloids, and noble gases. Our metals are found to the left of the zigzag line. Their physical properties include luster, meaning they're shiny, they're good conductors of heat and electricity, and they're malleable. Our metals are shaded in blue on this periodic table. Then we have the nonmetals, found on the top right of the periodic table. They have similar physical properties as well. They're brittle and they're poor conductors of heat and electricity, so they're good insulators. They are shaded in yellow on our periodic table. Then we have our metalloids. They are found touching the dark zigzag line. Elements that share properties of both metals and nonmetals make up the metalloids. Our metalloids are shaded in green along the zigzag line of the periodic table. Last, we have our noble gases. They are found in group 18. They're all gases, and they rarely combine with other elements because they have a full outer shell. They're the ones shaded in yellow with black lines across them, just that very last section down there, number 18. I hope you guys learned something. We'll continue talking about the periodic table as we move through this unit.